Greetings, hackers! Glad to see you again. Today we have a new topic, paged memory organization. Typically, databases deal with large volume of data. Here, petabyte is not a limit. We sometimes deal with databases more than a petabyte. This volume is much larger than available memory, than available RAM, read alternative memory. And to organize data processing inside a database, we need to use technologies, tricks, and algorithms for paged memory organization. Page is a typical term you can find in a scientific paper on databases, and a typical word which you can find in a technical documentation for almost every serious database. Typically, page is a chunk of a data, usually 4 or 8 kilobytes, but now we are talking a lot about huge pages which are much larger, say 32 megabytes. You can find pages not only in databases. Pages are typical for file systems, typical for operation systems. Sometimes you are talking about pages when you deal with the network and even computer graphics. Usually page has its representation on disk or on some permanent storage and in fast memory. If we are talking about Postgres, we have so-called blocks. Block is a part of a file. So we have a block number. This is a number of a block inside a file. Essentially, block number means page address, but block is just a raw data. If we are talking about page means formatted block which contains header, which contains specific structure, which contains maybe data. So in Postgres, block number is just 32 bits unsigned type. But we have two types for block number itself and block ID data. Block ID data is a storage format for block number. It contains two separate fields, two unsigned 16 bits integers. This is useful on some specific platforms to get a better alignment, more compact alignment of block numbers on a physical page. When we talk about code object, page in Postgres source code, page is just a pointer. This is a pointer into a memory which represents data of block. Usually page in Postgres is 8 kilobytes, but for different scenarios, other page sizes are optimal. Page size is a very important parameter of your cluster. You can't recreate your database easily recreate your database with different page address. You need to organize every file in database if you change page size or block size in Postgres terms. Code object page has a beautiful documentation in a code. You can see it in comments of page type. And later we will discuss this schema, this picture of what's inside the page. Page is represented via buffer. It can reside only on disk or on disk and in shared buffers. This is a specific part of computer memory which is devoted to making access to disk pages faster. So if you want to read a page, first thing you do, you place a pin on a page. This means that this page have to be in a memory to access its data. When you release pin from a page, means that page can be evicted from buffer to free space for free buffers, free frame buffers, buffer frames for other pages. When you use data on a page, first thing you have to do is to say that you are reading a block by calling a function read buffer. You provide this function with a block number, and it returns you a buffer, the place where your page actually resides. Next thing that you have to do, you have to lock this. Usually you log for read or for write, or make a shared log or exclusive log. Exclusive means exclude all writers and readers. This page now is only for you, and you can freely modify contents of this page. To get an actual pointer into a buffer, you have to call a function called buffer get page and provide it with a buffer. After you change anything on a page, you have to mark it dirty. Dirty means changed in a memory. This means when a page is evicted from memory, its contents have to be written on disk because it changed since it was read from the disk or since it was created. After you have done everything you need with a page, you have to unlock buffer and release a pin on a page. You can do this with just one call, unlock release buffer, or with calling separately lock unlock and release buffer function. Now let's talk more about what's on page.